Hello students, in this video we're going to study some of the behavior of this particular vector field. If you haven't seen the simple position vector field or the vortex field introduction, I highly recommend you take a look at those two videos. Also, take a look at the videos where I compute the divergence and curl of the position vector field and the vortex field, because I use that later in this video as well. Or you could watch this entire video and then go back and catch up by watching those videos. It's entirely up to you. All right, so this is called the hurricane field. I'm going to write it this way. And if you're wondering why does it behave in this particular way, well, if you take a closer look at this vector field, you can see that we can write it as x comma y plus minus y comma x, and you look at that and you see that, hey, that's the position field and that diverges, and this is the vortex field and that curls. So you have the vortex field that's curling around, but you are adding in the position field that is pushing that swirling motion out. So this is a combination of both those vector fields. We can think of this in 3D. I can add a z component onto this, and so then we'd have um, a swirling, diverging field from the origin. And the reason I'm going to do that is I'm going to compute the divergence and curl of this vector field. So the divergence, just by definition, is grad dot f, and so um, the divergence operator is linear, so that means I can take the divergence of this term plus the divergence of this term. That follows just from the linearity of a derivative. So divergence of xyz, recall in a previous video, that's 3. That's because dx dx plus dy dy plus dz dz is 1 plus 1 plus 1 is 3. And the divergence of this field is 0. That's easy to see because if you compute the divergence of if you compute the divergence of this field, then d dx of minus y is 0, dy of x is 0, and dz of 0 is 0. So it's like the derivatives miss the respective variables, so you get a 0 there. So the divergence of this field is 3, and that was the divergence of the position field that we had computed in a previous, of this divergence field that we had computed in a previous video. If I compute the curl is also a linear operator with respect to addition. So I can just distribute the curl operator, and recall in a previous video that when we computed the curl of the position vector xyz, we got 0, and when we computed the curl of the vortex field, we got 2k. And so that tells us that we want to call this the hurricane field. The divergence of the hurricane field is 3, so we get a positive divergence because it's rotating outward, and the curl of the hurricane field um, is 2k. All right. I hope you enjoyed that. Good luck.